Hi folks, we're going to take a look at an example of factoring a polynomial using the factor theorem and also synthetic division. So I take a look at this polynomial that I want to factor, and I notice first of all that the leading coefficient is equal to 1, so that's good. So what we saw was that the possible x-intercepts are going to be found by looking at the factors of the constant term, which in this case here is 64. Now the bad news is that 64 has a lot of factors: 1, -1, 2, -2, 4, -4, and so on and so forth. Okay, so we're going to go in order, and we're going to have to hope that the number's not too high. Okay, so the first thing we do is we start testing out, and I'll start at 1. So I'll start with f at 1. Now I don't necessarily expect you to write this out. When the numbers get larger, you might want to write this out, since it'll get a little more complicated. Okay, but let's take my calculator here. I could do this in my head, but since there are some larger numbers, I will use a calculator. Okay, so what do we have? We have 1 to the 4th. So we have 1 plus, this is 3 times 1, so just plus 3. And we realize the x components, regardless of the exponent, is just always going to be 1. So we have 1 plus 3 minus 38 plus 24 plus 64 equals, well, I actually don't care what the number is. The only thing I care about is that it's not equal to 0. Okay, so we'll move on to the next one. Before I move on to 2, let me try -1. Okay, so again, I think this is one that I can do a lot of in my head here. Okay, so anytime the exponent is even, I know that it's going to make the negative number a positive, whereas when the exponent is odd, it's going to keep the negative sign. So this here is just going to be equal to 1. Okay, this is going to end up being -3, because the x cubed is going to be equal to -1, so -3. This is going to be, the x squared is going to be equal to +1, so I'm just left with a -38. Okay, but here I'm adding 24 times -1, so it's going to be -24. Okay, and then here lastly is just a constant, so plus 64. And look at that, oh, we got lucky. F at -1 is equal to 0. Okay, now remember what the factor theorem tells us. Now if this didn't work, I would just keep going till I hopefully found a 0. Okay, so what the factor theorem tells us is that if f at -1 is equal to 0, means x minus -1 is a factor. But of course we don't write it as x minus -1, we write that as x plus 1. So I know that x plus 1 is a factor. So if I divide these two functions, I know that the remainder is going to be equal to 0. So that's step 2. Step 2 is now to divide this function. Okay. So again, I'm just going to work with the coefficients with synthetic division. So I've got 1, 3, -38, 24, 64. Okay, and here my a value is -1. Okay, so bring down the leading coefficient, 1. -1 times 1, -1. Add these two. 3 minus 1 is 2. Multiply. -2. -38 plus -2 is -38 minus 2. So -40. Okay. Now we keep going. -1 times -40 is positive 40. Add them. 24 plus 40 is 64. -1 times 64, -64, and as expected, even though I know that the remainder should be equal to 0, I just test it out to make sure, because if it's not, means I either made a mistake in my synthetic division, or -1 is not going to be a 0 of that function. So what does this mean? This means that f at x can be written as my first factor of x plus 1 times the quotient x cubed plus 2x squared minus 40x plus 64. Okay, so I have this factor of x plus 1 that's done, but now I'm left with this cubic. Now with this cubic, I see 4 terms. The first thing I should try to do is see if I can factor this by grouping. Okay, but I look here, if I factor out the x squared, I'll be left with an x plus 2. And if I factor out, well, there's nothing I could factor out that's going to give me an x plus 2. So what does this mean? It means I have to use the factor theorem a second time. Okay? So again, I see leading coefficient of 1, so no issue there. So I'll just call this thing g, just so that I've got a name for it. And again, I have this 64. So I'm going to have to keep looking for factors of 64. So here we'll try g at 1. Now, do I actually need to check g at 1? Okay. If 1 made this expression 0, then the whole thing would be 0. It would have made f equal to 0. So I actually don't need to check g at 1, because if it doesn't make f equal to 0, there's no way it's going to make g equal to 0. I should still check g at -1, because it is possible that we have two factors of x plus 1. There could be an x plus 1 squared. So we should still check this out. So let's see if this is equal to or not equal to 0. So we have 1, okay, sorry, -1 because it's cubed. This is just going to be plus 2 because it's squared. So -1 plus 2 is 1. This is going to be plus 40 because of the -1. Plus 64 is definitely not equal to 0. If you prefer, you know, put it in the calculator here, and we have -1 plus 2 plus 40 plus 64 not equal to 0. Okay, so let's move on to the next one. Let's try g at 2. Okay, let's see what that gives us here. Okay, so this one here I will actually calculate it. So we've got 2 cubed, okay, plus 2 times 2 squared, okay, minus 40 times 2 plus 64 equals 0. There we go. We got lucky. It was the next one over. Sorry, this one's not equal to 0. This one is. Okay, so what does the factor theorem tell us? The factor theorem tells us that if g at 2 is equal to 0, then x minus 2 is a factor. Okay, so now I do the same thing. I divide this by x minus 2 to find the quotient. So 1, 2, -40, 64 divided by x minus 2. So there's my representative of x minus 2. So 1, 2, add them 4. 2 times 4 is 8. Add them -32. And even though we don't need the remainder, it should be 0. Let's check it. 2 times -32 is equal to -64. And when I add them, I do indeed get 0. So this means now that f at x, our original polynomial, can be written as x plus 1. Okay, our second factor of x minus 2 times the quotient of that last division, which is x squared plus 4x minus 32. Okay, and what's nice here is that I've got a quadratic. So if I'm looking for the zeros, I can either factor, hopefully it'll factor nicely, or worst case scenario, I could always use the quadratic formula to determine the other two x-intercepts. But actually, I think this factors nicely, because if I think what are two numbers that multiply to -32 and add up to 4, well, we have 8 and 4. So we have x, since it's plus 4, it's going to be x plus 8, x minus 4. You could always do a quick check. -4 plus 8 is positive 4. And there we have it. There's our factorization. Okay, so let's just do a recap. Step 1, determine one of the zeros by guess and check, but not just any numbers, only numbers that are factors of the constant term. In this case here was -1, so x plus 1 is a factor. I divide to find the other factor. Okay, this is a cubic which can't be factored easily, so I use the factor theorem again, found that g at 2 is equal to 0, so x minus 2 is a factor. Divide to find the third factor, and that third factor was a quadratic, so I can factor it by traditional means. Okay, that's it for this one.